Today's lesson is on the sine, cosine, and tangent for acute and obtuse angles. We will be talking about the value of each, what it means on a graph, and supplementary angles. And you will accompany with it with day 3's worksheet. So acute angles are angles that are between 0 and 90 degrees. Whereas an obtuse angle is between 90 and 180 degrees. Remembering that a 90-degree angle is called a right angle. So in your calculator, in my calculator, I'm going to just punch in these numbers and get them. So sine 30 is 0.5000, because we're at 4 decimal places. Cosine 30 is 0.8660. And tangent 30 is 0.5774. We can punch in some obtuse angles now, and we get the value of the sine to be 0.6428. The cosine to be negative, so there's something new. The cosine of an obtuse angle is a negative number. And the the tangent of an obtuse angle is also negative at 0.8391. You could always take a minute and try this in your calculator to ensure that you can do it without any problem. So moving on to the next slide, we have acute angles, where we can just recap what we learned. For a sine of an acute angle, it's positive. And the cosine of an acute angle is also positive. And the tangent of an acute angle is also positive. Whereas when we get to obtuse angles, those angles greater than 90, we have, and less than 180, the sine is still positive. Cosine is negative. And the tangent is negative. So that was just a quick recap of what we learned on the other slide. Now, if I think about a coordinate system, or a coordinate grid, they are labeled. We have quadrant 1 right here, quadrant 2, and working our way around the circle, we would have quadrant 3 here and quadrant 4. We're not too concerned with those right now because we're talking about angles between 0 and 180. And if we said we were starting from the origin, or from point A, and this here being 0 degrees, we would cover all the way to 180 over here as we moved around our circle. Well, if we choose a point, any point in the grid, let's choose this point right here. We'll call this point P, and this will be at 1, 2, 3, 4, 4 in the X, and 5 in the Y. Remember our X and our Y axes. We always label points like that. Well, if I was to make this into a triangle, like this would be triangles, a right angle triangle with a base of 4 and a height of 5. The hypotenuse, we don't know the length. We could find it, but we don't need to. Well, in this case, if I was to take the sine of this angle, and the angle I'm talking about is angle A, which is right here. If I was to take the sine of that, well, sine of A, or may as well, I did label theta in the picture, so sine of theta would be a positive number because we would have opposite over hypotenuse, a positive over a positive, so it would be positive. The cosine of theta, again, using adjacent and the hypotenuse, would also be positive, and the tangent would be positive by the same reason. It would be a positive numbers. Well, if we move our point over to the other side of the graph, here, we'll call this point Q. Well, point Q has the coordinates of -4 and 5. So we draw in a triangle to represent this one. So in quadrant 2, and this is where our angles would be greater than 90, but still less than 180. Okay, well in this case we'll call it theta again, or we'll call it phi this time. Well, we would still have 5 here, but this becomes -4. So this might help to explain why the signs change. Well, sine of this angle, it deals with the hypotenuse and the positive phi value across from it. So those are both positive, so it still stays positive. The cosine of the angle phi would deal with the hypotenuse, because remember, cos, adjacent over hypotenuse, and it would deal with the adjacent. Well, the adjacent when you're over here is -4, so this creates a negative number. And the tangent of phi would deal with the opposite over the adjacent. So again, we have one negative, so it would turn negative. So from the graph, that helps us to explain why the signs do this. So you see, for no matter what, if we have an angle between 0 and 180, it will always be positive on sine. Cosine is positive up to the angle of 90, and above 90 it is negative. Tangent does the same thing as cosine. And the final slide in today's note is to do with supplementary angles. Supplementary angles are two angles that add up to 180. So in this case, we're just asked to solve 3 problems that pretty much take us through what we need to do to get this done. And we can say, well, the sine of the acute angle P, so acute angle P, is 0.6561. So we say sine P equals 0.6561. Well, that means P equals the inverse sine of 0.6561. P, in our case, rounded to the nearest degree, is 41. Well, we are told that for supplementary angles, they are two angles that add up to 180. So I'm going to let the sign of all my supplementary angles in this one be A. So I would say A plus P equals 180. So A equals 180 minus P. Because these two angles must add up to 180. Therefore, if I take one away from 180, I would be able to find the other one. A equals 180 minus 41. And finally, I get that the supplementary angle of in this question is 139 degrees. Let's repeat the procedure just using the cosine and the tangent here. So the cosine, we do the same thing. Cosine of angle R equals 0.2222. I put in the inverse cosine and I find out that angle R is 77 degrees. So A would be 180 minus R. And A would be, well, 180 minus 77. And we get here A equal to 103 degrees. So you can see it's fairly straightforward, this work. And finally, the last one, again, tangent of angle S equals 0.4400. I do the inverse tangent, and I find out that S is equal to 24 degrees. A equals 180 minus S. A, 180 minus 24. I know I'm going very quickly. And angle A, in this case, equals 156 degrees. I would highly recommend that you try this on your calculator. Now, today's work, if you have a look, determine the sine and cosine of the tangent of each angle. So you just have to punch that through your calculator. and then it says, is the trigonometric ratio positive or negative? So you're not trying to solve it, you're just telling me if it's positive or negative. If you see the second slide, that'll help you with that. Each point on this coordinate grid makes it right angle with origin A. Determine the indicated trigonometric ratio. You see, it's not asking you to solve it. They're saying sine A and point P, so you're doing the sine of the angle here using point P, so you would draw a triangle and you would solve that. They aren't asking you to solve it, they just want you to set up the ratio. Number 4, suppose angle P is an obtuse angle. Determine the measure of angle P for the given sine ratio. So that's just like the last 3 examples we did in the note. And then question 5, give the measure to the nearest degree. So you're just going to use the inverse there for the cosine. Determine the measure of angle Q for the tangent. So again, you're going to use the inverse tangent and solve that. Here you'll have to tell me, based on the sign, is it acute or obtuse? Tell me how you know. Check the first 2 slides for that. Complete the table using what we did in the note in the second and third slide. You should be able to complete that, mainly using the one with the graph and the quadrants. The measure of angle P is between 0 and 180. Which equations result in 2 different values for P? So that's an interesting question. How would you know if you had 2 possible values or 2 supplementary angles based on those numbers? And number 10, determine all the measures of angle A in the triangle given each ratio. Explain your thinking. So where can you have 2 different measures of A and why? Okay, so number 11, figure out the angle, then figure out the sine of it. Okay. Number 12, the sine of an obtuse angle is 12 over 13. Calculate the cosine of this angle to 4 decimals. So again, very similar to number 11. And 13, 14, and 15, I'd like you to try on your own. Good luck with the work. And if you have any questions, don't forget to come and see me and I can explain things in greater detail.